This is User-Defined Functions Part 2. I'll be showing you examples of UDFs for audio application and more nuts and bolts of AUXLAB related to UDFs. Here's our first task. Inspect all the WAV files in the folder, then show the RMS of each sound. The name of our first UDF is OpenShowRMS. So the first line goes function y equals OpenShowRMS. Then the parameter is the path, which is the directory of the files. Then to get the files, we are using the function dir. This is the same as the command dir in the console or the command window. Here the ++ operator is the concatenator, appending the string back to back. In other words, the function parameter is the path followed by start.wave. Then we are setting up a new variable RMS data, a vector of zeros now with the size of the number of WAV files. Now entering the for loop to work on each file. First, we open the WAV file. The variable files we got as the result of the dir function above is a cell array, so you access each of them with braces. And each of these is a class or structure object with a bunch of properties, so we access them with a dot notation. For now, focus on the file name, so just put dot name. After getting X, the audio data from the file, get the RMS and put it into the variable RMS data. That's pretty much it. You copy RMS into Y, the output of the function. Before we move on, let me show you another way to do it. Look at lines 3 and 6. It's simpler this way, but there are pros and cons. Now save the file. Make sure to save it as the same name as the UDF, show_openrms.aux. We just saved this file in the same directory as AUXLAB program, but we may want to put it in a dedicated folder. Let's try that. Create a folder UDFs and move OpenShowRMS.aux there. Then go into the system menu of Settings and Variables window, select Set UDF Path. There you can specify the UDF path. Close the program and come back. Ctrl O to open the UDF file and select the file. Or you can click the debug icon. Let's look at the folder of WAV files. These are the files to work on. We are ready to try, but before we do that, I'm going to show you how the function dir works. Call the function dir with a directory followed by star.wave. The result is a cell array size of 8. Each of them is structure or class object. Click one of them. You see the properties of the file. We are using only one of them, .name. Before you run it, set the breakpoint at line 3. Now let's try. OpenShowRMS and the path, C, sound files, test, and it'll stop at line 3. On line 3, files is ready, the size of 8. Press F10 to step again, X is ready, plot and play it.
I just saw Jim near the new archaeological museum.
Press F10 again, RMS data has been updated with the first sound. Press F10 again.
The surgeon carried a cage of live pigeons.
Now we have new X, the next sound on the list. Notice that K is now 2. I changed the breakpoint to line 6 and pressed F5 to run through line 6 for the next cycle of the loop. As I press F5, the updated X is on the screen, so we know what sound is being processed.
They're clearing the table
In each loop.
The girl planted a vegetable garden.
Now K is 7. Double-click RMS data. We see that we have 2 more data points to fill in. Press F5.
Thin books look bright.
And F10. On line 8, we are ready to exit. Let's check the result, RMS data. Yes, we have all the data. Press F10 and press F5. You can modify the UDF some custom way. You may want to add some text message on the screen, for example. In this case, the name of file. So I revised the function a little bit on the side and reload it here. So I'm using the function figure to get the figure handle of the name plot X. Also the function text to make text message on the screen. I'm not going over the details of each of these calls, but hope you can figure it out. So with this, as you press F5, you see the name of file as well as the waveform on the screen. Otherwise, it's the same function. Now, we have new mission. So for all WAV files, we want to process each of them in the following way. First, each sound must have certain duration of silence, 200 milliseconds, before the actual signal. And we save each file as a new name, REV, at the end. So let's work on the file that we already have. First, change the name of UDF to long but informative name. Before I forget, I'm saving the file as the new name. I'm getting rid of some lines here and defining the variable overall RMS for the RMS of the audio. I'm defining the variable TP, time point, used in the while loop. X part is extracted part for each 50 millisecond time period. The exit criterion is it will break from the loop if the RMS of the extracted part is below 5 dB, less than overall RMS. TP is increasing by 25 milliseconds, and X part is updated. That's pretty much it. Now, new signal is silence for 200 milliseconds, followed by X from the last value of TP till the end. Then we are generating the wave file. The file path followed by the file name and REV. Now let's run the UDF. Oops, we have an error. Oh yes, on line 15. Yeah, we no longer have the variable RMS data. So let's get rid of that. And while we edit the file, let's add another line showing the message of what file is processed at each time. fprintf 0, it'll make formatted string output on the console. Now let's run again. It runs, but we have 16 files made. Sorry to confuse you, I actually ran on the side. Already generated 8 files, so now we have 16 files made. So when you see this folder, you see some files have name rev. I'm getting rid of these files for the next operation. Now I'm going to show you yet another way to use UDF. You can define another function inside the function, which has only the scope within that UDF. This is similar to sub function in MATLAB. We'll call this local function in AUXLAB. So I'm grabbing this part and make a local UDF. Now the local UDF is ready. Let's call it. Adding some friendly information for the screen. Now I'm adding another line. I want to show you how you can set the output RMS, a certain value. I want to make all the output at negative 20 dB. Adding more information about the RMS for the screen. Let's run it. It runs okay. The message on the screen is how we intended. These are files in the folder. See 8 files generated with REV at the end of the name. Now let's compare before and after. Pick one file. I'm going to show you one more way to maneuver in the debugger, stepping into the local function. So set the breakpoint on line 5. On line 5, press F10 to move to line 6. But here, line for the local function, press F11, then step into the local function.